Welcome to Week 1 Lab Lecture. What you're going to be doing this week in Lab 1 is we're going to be looking at utility history and something called EUI development. The first thing I want to discuss is something called Energy Utilization Index, or formerly known as EUI. The Energy Utilization Index is the total kilobTUs of energy used by a building per square foot over the course of a year. So the units of EUI are kilobTUs per square foot year. The energy use is from all sources of energy used by the building, such as electricity, natural gas, propane. In other words, any energy used over the course of the year in the building, no matter what it's for, heating, lighting, whatever, is first converted to kilobTUs, and then it's divided by the square footage of the building, and again it covers all the utility usage over the course of the year. Now, how is the Energy Utilization Index utilized? Basically, it establishes a baseline or benchmark energy usage for a building. What I want to do is take a year's worth of all utility billing and come up with some sort of number that equates to energy usage per square foot that I can be used, or I can use it later on to compare after I do future energy projects. In other words, I'm getting ready to do a complete lighting retrofit. If I know the starting energy utilization index, I can go back and calculate a new energy utilization index after a major energy project to determine the success of my previous energy project. The second usage for energy utilization index are comparisons with similar buildings in similar climatic zones. Now, the government uses a website called CBECS, which stands for Commercial Building Energy Consumption Survey. Now, the government maintains this website, and again, it's for commercial buildings, not industrial buildings, and it was meant as a voluntary survey by commercial customers to log in their overall energy usage. It's a way to go in and potentially look for similar buildings, again in similar climatic zones, that you can compare your own building with. Now, again, like we talked about before, to get an energy utilization index, you need to convert all forms of energy use within the building into kilobTUs. If we look at electrical first, we have to take the energy use, which is kilowatt hour, and for every 1 kilowatt hour, there's 3.412 kilobTUs. So you use the monthly energy use as seen on this slide. In the example, the electrical usage bill on the previous slide had a monthly energy use of 7,200 kilowatt hours. If we multiply this by the 3.412 kilobTUs per kilowatt hour, we get 24,566 kilobTUs. We would do this for every month until we get a year's worth. So we do 12 consecutive months. Doesn't necessarily need to start in January, although convenient, but it can start at any time during the year, and as long as we get 12 consecutive months, we can use this to calculate the EUI. The next thing, in a typical building, most buildings use natural gas for something. The conversion of natural gas would be 1 therm is equal to 100 kilobTUs, or 1 CCF, again 100 cubic feet, is approximately equal to 100 kilobTUs. Now, A lot of natural gas bills will have an energy conversion right on the bill. If they don't have an energy conversion, if they're using gas by volume, then it's okay to use the 100 kilobtus per CCF. Now, you want to use the CCF used for the month. Be careful. Some utility companies actually have a historical usage which is average per day. Don't get this number confused with the monthly usage. Make sure you use the monthly usage for natural gas. In the previous example, they have a monthly 100 cubic foot usage or CCF usage of 1,066 CCF. There was no energy conversion on the bill, so we can go ahead and use 100 kilobtus per CCF. So we multiply the 1,066 CCF times 100 kilobtus, and we get 106,600 kilobtus for this month's natural gas usage. Just like electricity, we would repeat this for 12 consecutive months of natural gas usage. Now, it's important to realize when we do this, we need to have the natural gas bill and the electric bill line up. So if we start the electric bill in February, we need to have that month's natural gas bill, and so forth. So all the energy usage for the same month need to be the starting point, and we need to run 12 consecutive months of similar energy bills until we get to 1 year's worth. After all the energy source bills are converted to kilobtus for 12 consecutive months, all of the kilobtus are added together to get a total kilobtu for all energy sources used for 1 year, or 12 consecutive months worth. This number is then divided by the total square footage of the building. This gives us the EUI. Now, we may stop at that point and have ourselves a baseline or a benchmark that we can use after we do future energy studies. The other thing we can do is take this EUI and do it as a comparison, again, against the government's website called the Commercial Building Energy Consumption Survey. We already discussed that it's a voluntary submittal by commercial buildings only, not industrial. How do we get there? Step 1. If you Google the acronym CBECS, the first entry that'll come up is the Commercial Building Energy Consumption Survey. This is the website you want to go to. Once you're there, this is the main page. The first thing you have to determine is the climatic zone that your building is located under. So over here on the right-hand side, you'll notice that there's a CBECS maps. That's where you want to go next. When you get there, you need to scroll down until you get climatic zones for the Commercial Building Energy Consumption Survey. Notice how there's 5 zones, color-coded. Now these zones are also based on, if you look down here under the legend at the bottom, by a combination of cooling degree days and heating degree days. So if you happen to have a location that is sitting on a border between climatic zones, you can go down here and look up that particular location's cooling degree day or heating degree day from a weather website and get a more precise definition of what climatic zone your location is under. Once you have the climatic zone and write it down, you need to go back to the starting page, and you now need to go to the archived reports. Once you're in the archived reports, you want to go to the data tab. It's the second one over as shown by this arrow. Underneath the data tab, we're going to be using the 2003 results. 2003. I realize there's more current data, but for this exercise, you're going to be using 2003. Once you're in the 2003 data results, you need to go to the Consumption and Expenditure tab. Consumption and Expenditure. Within the Consumption and Expenditure tab, you want to come down and you want to select or expand the Consumption Expenditures for all building types tab. Once you're under the Consumption and Expenditure for all buildings tab, you want to slide down and you want to pick table C10A, the Consumption and Gross Energy Intensity by Climatic Zone. And you're going to open the PDF form, the Adobe PDF form. Once you're in this, notice that I'm in table C10A, Consumption and Gross Energy Intensity by Climatic Zone for all buildings. The way it's laid out is we have buildings ranked by various things, square footages, usages, whatever on the left-hand side. And across the top, we have the zone that you picked before, 1 through 5, and then we have different main categories. Sum of major fuel consumption, total floor space of building, and then finally, notice this, energy intensity for sum of major fuels. The unit for this is thousands of BTUs, which is kilobtu per square foot. These numbers under here were based on annual energy usage. So this final column over here is the EUI. So if I had a building in Zone 1, the overall EUI for all building types for 2003 was 94.2. This is the energy utilization index for all buildings under Zone 1. Now, what you're going to need to do is I want to do it by building type. So you need to scroll down. If you scroll down, it has principal activity, building activity. So what was the principal activity? The government has some definitions of common activity. So if you look at this, we have education, food sales, food service, healthcare, inpatient, outpatient, lodging, etc., office building, whatever. If I happen to have an office building in climatic zone 1, if I slide all the way across where the red arrow is, under zone 1, in 2003, a typical office building had an energy utilization index of 90.7. You could use this number to the calculated EUI that you had. Now, if your EUI is higher, that means you're using more energy than a typical building in that climatic zone. This might indicate that you have more potential than the typical building to get energy savings. Now, if your number is less than this, that means that you're doing something better. You may have a more difficult time finding more areas to save money with energy conservation projects. Now, one area that you're going to do in the lab this week is I actually included a spreadsheet to calculate energy utilization index. So in one part of the lab, you're going to take the spreadsheet that I gave you and you're going to fill in the details from actual utility bills to have the spreadsheet calculate the energy utilization index. Now you need to note when you go into the actual spreadsheet, the Excel spreadsheet, you only fill in the yellow boxes. Do not fill in or change anything in the white boxes. Those are going to calculate stuff for you. So you're going to type in all the kWh from the utility bills, all the CCF from the utility bills. If there's a variation in content, now this is defaulted to 100 kilobtus per CCF. If that has to vary at all, you would change that. If not, you leave it. Then you would type in this building square footage here, and it will tally all the kilobtus together, divide by the square footage, and calculate an EUI. So you'll be using a spreadsheet as part of Lab 1 also. So the previous slide has the example of the simple EUI calculation spreadsheet. Again, you only fill in the yellow cells. Make sure all yellow cells are checked and filled in correctly, including the building square footage, and you'll have this spreadsheet as part of the Lab 1. Now, Lab 1 has actually 3 parts. It says 2 parts, really 3 parts. Part 1 is a manual calculation of kilobTUs. It's part of a form. Part 2 is using the Commercial Building Energy Consumption Survey. You'll be answering some questions, also part of the form. And Part 3 is using the spreadsheet that's also part of the attachment and real utility bills that you have available, and letting the spreadsheet calculate an EUI. Now, what I'm expecting as a deliverable from Lab 1 is the filled out Lab 1 form and a filled out Lab 1 spreadsheet. You're going to attach both the form and the spreadsheet back to me, both renamed using some form of your name in the file, and that's what I'm going to grade on. Again, make sure that you're very conscious about the due dates for these. This ends Lab Lecture 1. You can proceed to Lab 1, and again, make sure you have an understanding of due dates. Thank you.